everybody. So in this video, we are going to discuss a very important thing as per Olympiad point of view, that is Vietas relations, which will give you the relation between the zeros and coefficients of a polynomial. So let's start with the discussion. So that's a general relation for, every type of polynomial. So for example, if I discuss it with respect to a quadratic polynomial, you see this ax square plus bx plus c, correct? Suppose the zeros are alpha and beta over here, right? So the sum of the zeros is what? Minus b by a, and product of zeros is what? C by a. You see, I'm not discussing the derivation of it over here. I did discuss the derivation on the Infinity Learn class 9 and 10 YouTube channel many times, that why the sum of the zeros of a quadratic polynomial is minus b by a and product of the zeros of a quadratic polynomial is c by a, right? Over here, I'm just discussing the, pattern over here. Now, suppose you take the cubic polynomial, ax cube plus bx square plus cx plus d. Let me first write it. Suppose the zeros are alpha, beta, gamma. So the sum of the zeros will be what? Minus b by a. If you take two zeros at one time, alpha, beta, beta, gamma, alpha, gamma. That is c by a. And if you take the product of zeros, alpha, beta, gamma, that is equal to minus d by a. So you see, I'll explain the pattern over here. I forgot to take the linear polynomial as well. If you take the linear polynomial ax plus b, it will have only one zero alpha, that is minus b by a. Now you see, whatever may be the degree of the polynomial, whether 1, 2, 3, 4, any degree, if you take one zero at one time, and add them, it is every time minus b by a. You see, it is every time minus b by a. For a linear polynomial, for a quadratic polynomial, and this is for a cubic polynomial. If you take one zero at one time, it will be every time minus b by a. You see this. And if you take two zeros at one time, you see two zeros at one time. In this case, two zeros are not possible. But in a quadratic polynomial, you can take two zeros at one time. In a cubic polynomial, you can take two zeros at one time. So what is the pattern? You see, it was minus b by a. It will be plus c by a. See the pattern. From minus b by a to plus c by a. Sign is changing from minus to plus and from b to c. And then if you take three zeros at one time, see over here, three zeros are not possible. It is only possible in a cubic polynomial. So again, see the pattern. When you take three zeros at one time, from c by a, it will be minus d by a. You see, sign is changing. Minus plus minus. B, C, D. You see the pattern over here. I hope that is clear. Now suppose same logic, I extend it to a 4-degree polynomial. The standard form of a 4-degree polynomial will be what? Ax raised to the power 4, bx cube, cx square, dx plus e, right? This is the standard form of a 4-degree polynomial. Now suppose the zeros are alpha, beta, gamma, delta, right? Now again, over here as well, if you will take one zero at one time, that is alpha, beta, gamma, delta, it will be minus b by a. What did I say? Whatever may be the degree of the polynomial, if you take one zero at one time, it is going to be minus b by a every time. Now if you take two zeros over here, right? Two zeros, how will you write? It will be alpha, beta, beta, gamma, then gamma, delta, right? Now there are more in it, right? You see alpha, beta, beta, gamma, gamma, delta. Then you can write alpha, gamma. Then you can write alpha, gamma. You can write alpha, delta. And then if you start with B, you can write beta, delta as well. You can write beta delta as well. Now what is the pattern? See, it was minus b by a, sign will change to c by a. See the pattern. Minus b by a to plus c by a. That's the pattern. Now one thing you have to remember in a cubic polynomial, in a 4-degree polynomial, that this thing, if you will factorize it, this thing if you will simplify and factorize, you will get it in this form basically. Alpha plus beta into gamma plus delta, and then that is alpha beta plus gamma delta, and that is equal to c by a. I hope that is clear. This is very important form. I mean, this thing is coming from this thing only. Just rearrange and factorization. It is very much expected from a student preparing for a competitive examination to know factorization, right? So you'll get something like this. This thing is very important. Alpha plus beta into gamma plus delta, and then alpha beta plus gamma delta is equal to c by a. So 1 0 at one time, 2 zeros at one time, right? And then you can take 3 zeros at one time. 3 zeros at one time will be what? Alpha, beta, gamma, delta, and then what will have? What you will have? Alpha, beta, gamma, delta. Then you will get alpha, gamma, delta. If I'm not wrong, just check it properly. That will give you alpha, gamma, delta. And one more thing will be there. Wait, alpha, beta, delta as well. Alpha, beta, delta as well. You can check it. You see this? Alpha, beta, gamma, delta. Then alpha, gamma, delta. And then alpha, beta, delta. I hope that is clear. There is no other thing. Now you see, it was, if you are taking 1 0 at one time, it is minus b by a. If you are taking 2 zeros at one time, it is c by a. You see the sign change from minus b to plus c. And if you are taking 3 zeros at one time, from plus c, it will be minus d by a. This is very important, right? Now one more thing. When you take 3 zeros at one time in a 4-degree polynomial, you can remember it like this. This is basically alpha beta into gamma plus delta, and then gamma delta into alpha plus beta. That is equal to minus d by a. So you see, this thing is very important, this thing. And from where this is coming? It is just coming from the factorization of this thing, nothing else. You can obviously check it. You see, alpha beta you can take as common. You'll get gamma plus delta over here. Similarly, over here, you see gamma delta you can take as common. You'll get alpha plus beta over here. I hope that is clear. So this relation and this relation, you can say they are star relations basically. Fine. So I was taking 1 0 at one time, it was minus b by a. Then I was taking 2 zeros at one time. What is the pattern? From minus b, it is plus c by a. Then I'm taking 3 zeros at one time. From plus c, it is minus d by a. Then I will take 4 zeros at one time. What is that, guys? Alpha, beta, gamma, delta. So what will be the pattern? Minus d by a to plus e by a. I hope that is clear. That's the Vietas relations, and the same process will keep on going for more polynomials, for more higher order polynomials as well. Again, I will repeat, please see it patiently. If you take 1 0 at one time, it will be every time minus b by a, whether it's a linear polynomial, quadratic polynomial, or cubic polynomial, right? Or any 4-degree polynomial. So sum of the zeros, or taking 1 0 at one time, it is every time minus b by a. Then after that, if you take 2 zeros at one time, see the pattern. From minus b, it is plus c by a. From minus b to plus c by a, right? If you take 2 zeros at one time, from minus b by a, it is plus c by a, correct? If you take 3 zeros at one time, what is the pattern? From plus c by a, it is minus d by a. You see, if you take 3 zeros at one time, from plus c by a, it is minus d by a. And if you take 4 zeros at one time, from minus d by a, it will be plus e by a. That is the complete pattern. And two more important things I did discuss. If you have got a 4-degree polynomial, you see, if you take zeros 2 at a time over here, you have to remember like this, because this relation can be used many a times. You see, this will be very complex to think. I hope you understand. So you see, alpha plus beta, gamma plus delta, and alpha beta, gamma delta. You see the pattern. And when you take 3 zeros at one time, you can remember like this: alpha beta into gamma plus delta, plus gamma delta into alpha plus beta. I hope this is clear. Right? Now let's do some questions. 1 or 2 questions on quadratic polynomials I will take, and then we'll move on further. Let's start with it. So first thing, I'll go with quadratic polynomial. Any random quadratic polynomial I'll take. For example, it is x square plus 2x plus 3. Right? And please understand that they will try to give a polynomial which you will not be able to factorize in this type of questions. Because if you will be able to factorize it easily, you will be able to find the value of alpha, beta, gamma, delta, right? So they'll deliberately give you a polynomial which will not be able to factorize easily, right or not? So suppose for this quadratic polynomial, these zeros are alpha and beta. Fine. So the basic thing is, you can find alpha plus beta. Alpha plus beta is what? Minus b by a. That you have to remember. So that is minus 2 upon a is this, right? Coefficient of x square. And then alpha beta is what? C by a. That you know already. So c by a is what? 3 by 1. 3 by 1, which is 3. Fine. Now there can be many questions on this. I'll just take 1 or 2 questions. So suppose they ask you to find the value of alpha square plus beta square in this, for this quadratic polynomial. So whatever may be the quadratic polynomial given to you, you have to try to convert it in the form of alpha plus beta and alpha beta, so that you can use the relationship between zeros and coefficients of quadratic polynomials using identities. So you see, alpha square plus beta square can be easily written like this: alpha plus beta the whole square minus 2 alpha beta. This formula I did discuss many times. Now alpha plus beta we already know, that is minus 2 square minus 2 into alpha beta is 3. So what is that, guys? That is 4 minus 6 minus 2. You can obviously check for calculations. Correct? Obviously, I can also do calculation mistakes, but I hope concept is clear to you. Now sometimes they can give you alpha minus beta the whole square to find the value of this thing. So what did I say? Whatever is the expression given to you, try to convert it in the form of alpha plus beta and alpha beta. Because if you will try to find the zeros from here, if you will try to find alpha and beta from here, you can very much do that. But if you'll try to find it and you'll say that I'll plug in the values of alpha beta over here, it will take way more time. So instead of that, please try to convert this expression in the form of alpha plus beta and alpha beta. So basically, you see, this expression can be written like this: alpha plus beta the whole square minus 4 alpha beta. Now you see, alpha plus beta is already there. That is equal to minus 2. So minus 2 square minus 4 into alpha plus beta is 3. Alpha beta is 3. So what is this, guys? This is 4 minus 12. That is minus 8. I hope that is clear. And so on. I mean, it can keep on going. I'm giving you a homework. For the same polynomial over here, you have to find the value of alpha cube plus beta cube. Try it, guys, and comment the answer in the comment section after the class. For the same quadratic polynomial, find the value of alpha cube plus beta cube if alpha and beta are the zeros of it. Now let's move on to a cubic polynomial. For example, you see, this is a cubic polynomial. It is given that one of the zeros of this cubic polynomial is minus 1. Then you have to find the product of the other 2 zeros. You have to find what? Product of the other 2 zeros. So 1 0 is minus 1. The other two zeros are suppose alpha and beta, right or not over here? You have to find the product of the other two zeros. So can't you think that we have to use product of zeros over here? Product of zeros over here for a cubic polynomial is what? You see the pattern. If you take 1 0 at one time, it is minus b by a. If you're taking two zeros at one time, from minus b it is plus c by a. If you're taking three zeros at one time, from plus c by a it is minus d by a. It is minus d by a. So product of zeros over here is what? Minus d by a. Now what is d over here? You see coefficient of x cube. Maybe I will write capital A, B, C, D, because then it might create confusion. Wait. Because A, B, C they have used already. So minus d by a. Right? Now coefficient of x cube is a. This is b, this is c, and this is d. I'm talking about the coefficients. I hope you understand that. So minus d by a will be minus c upon 1 as per this polynomial. So you see this is going to be cancelled out. It means the product of the other two zeros for this polynomial, product of the other two zeros for this polynomial is equal to c. So that is the answer. C is the answer. But from the options you can't get, that thing. So basically we have to use some other kind of manipulation. You see minus 1 is a zero of this polynomial. What does it mean? It means that if in place of x I put minus 1 in the polynomial. In place of x I put minus 1 in the polynomial. It will satisfy the polynomial, right? It means that is equal to 0. It will make the value of the polynomial 0. That is the meaning of 0 of a polynomial. So from here you can find c, that's it. Minus b will become b. This is a will become minus a on the other hand side. And this is minus 1. If it goes on the other hand side, you'll get plus 1. So c is equal to b minus a plus 1, and that was equal to the product of the other two zeros of this polynomial. So b minus a plus 1. So that is b minus a plus 1. First option is correct. I hope that is clear. So you see this was the relation, this was an application of Vietas formulas or Vietas relations in case of cubic polynomial. Only one question we did. Suppose we take the same relation in case of a 4-degree polynomial. 4-degree polynomial is also called biquadratic polynomial, right? Biquadratic, or sometimes they call it quartic as well. So you see same logic can be used in an equation as well. Whether it's a biquadratic polynomial or it's a biquadratic equation, you can use the same logic, no problem in it. So you see the thing is, two roots of this polynomial have their product equal to minus 32 of this equation. You have to find the value of k. Fine. So let's start doing it. So you see two roots. Suppose first thing is we can, maybe I will write it A, B, C, D, right? Because I don't want to write alpha, beta every time. Suppose the roots of this biquadratic equation, they are A, B, C, D, correct? So the product of two roots is given minus 32. So suppose AB is given minus 32. Fine. AB is given minus 32. You have to find the value of k. Now you see some of the roots will be what, guys? A plus B plus C plus D. Some of the roots will be what? It will be minus B by A, right? So just see the coefficients over here. It is minus, and this time it is minus 18. So minus 18, and coefficient of x raised to the power 4 is 1. So that is basically 18 over here. That is the first relation, right? Now if you take two roots at one time, do you remember the relation which I was explaining? That is important in case of a 4-degree polynomial or a 4-degree equation. So when you take two roots at one time, the relation will be like this: a plus b into c plus d plus ab plus CD, if you remember that, right? Now what is the pattern? It is minus B by A, so sign change will be there, plus C by A, right? Now what is C over here? This thing, K. And capital A is coefficient of x raised to the power 4, that is K over here. Now I hope you understand, please don't get confused in that. I'm using capital A, B, C, D in the uppercase for the coefficients over here, and I'm using small letters A, B, C, D, the lowercase of A, B, C, D for the roots of this polynomial. I hope it's clear. Right? So this is the complete situation over here. And then if you take 3 roots at one time, what is the product, guys? What is the pattern? If you remember, that is AB into C plus D plus CD into A plus B. I hope that is clear. And that thing will be what? See the pattern. Minus B by A, C by A, it will be minus D by A. So minus, what is D over here, guys? You see A, B, C, D. That is basically 200. And coefficient of x raised to the power 4 is 1. So that is minus 200 over here. That is minus 200, right? This is the relations which we are using over here. Now if you take 4 roots at one time, that will be what, guys? A, B, C, D. 4 roots at one time. Now what is the pattern? Minus B by A, C by A, minus D by A. It will be plus E by A. It's going to be plus E by A. A, B, C, D, E. Right? So A, B, C, D, E. So that is going to be minus 1984 upon A is 1. I hope that is clear. Now you see product of 2 roots is already there, that is minus 32. So can I put AB is equal to minus 32 over here, and then BD is there, sorry, CD is there. Let me check it. Yep. Then you have got CD over here, right? Now let's find CD from this, guys. CD is equal to minus 1984 upon minus 32. Now let's simplify what we are getting. 16 2s are 32, 16 1s are 16, and then this thing, you are getting 62. It means CD is coming out to be 62 over here, right? CD is coming out to be 62. Now you have to be very patient about these situations. Just see that patiently, right? Now basically, so you know AB, you know CD, right? We have to find K from here, right? Now let's see the situation. Can I assume A plus B to be X over here? I can assume A plus B to be X over here. So from here, C plus D will be what, guys? C plus D will be 18 minus X, correct? C plus D will be 18 minus X. So if you see this portion over here, what is this? You see A plus B is what? A plus B is basically, A plus B is X from here, and C plus D is what? 18 minus X. That is 18 minus X. I hope that is clear. And you see AB is basically minus 32. So let's put it minus 32. And then CD we have got 62. So CD is equal to 62. And that is equal to K. So if you further simplify it, this is basically from here, K is basically X into 18 minus X plus 30, right? So it means if we are able to find the value of X, we can find the value of K. If we are able to find the value of X, we can find K. I hope that situation is clear to everybody over here. Now that we can easily do using this equation. See this. Because we know what is AB. AB is what? Minus 32. Let's put it over here, right? Now what is C plus D? C plus D is 18 minus X. It is 18 minus X. Then over here, what is CD? CD is 62. CD is 62 over here. And what is A plus B? A plus B we have assumed to be X. And that thing is equal to minus 200. So we have to solve this equation for x. That's a linear equation in x. You can easily solve it. So let's solve it, guys. If you open up the bracket, you'll get minus 32 into 18. What is that? Let's check it. Let's check it, guys. I guess that's correct. Let me check it once again. That is minus 576. Minus 576. Now you see this will be plus 32 plus 32x plus 62x, and that is equal to what? Minus 200. So what will you get from here, guys? This is basically 94. You see, this is 94x, that is equal to minus 200 plus 576. And that will be equal to what? 376. And I guess this is 4 times. 4, 4, 16, and this is 4 times. So what does it mean? That from here, x is coming out to be equal to 4. I hope that is audible and visible to you. So x over here is 4. Just check it. Let me check it once again. Correct. So x is equal to 4. You can easily plug in the values over here. You'll get the value of k. So I can put x is equal to 4 over here. So that is 18 minus 4, and then you have got 30. So what is this, guys? This is basically 4 into 14. So 14 fours are, maybe I will show you, that is 14 plus 30, and that is equal to 56 plus 30, 86. It means the value of k over here is 86. That is the correct answer, because I remember the answer. I hope that is clear, guys. So you see, on the basis of Vieta's relations, we have done this question. But the most important thing which you have to remember from this question is, for a 4-degree quadratic polynomial or a 4-degree quadratic equation, if you're taking 2 zeros at one time, you have to remember it like this. If you're taking 3 zeros at one time or 3 roots at one time, remember it like this. Otherwise, it will become very complex. I hope that is clear. That is the same thing, guys. So that's all we needed to discuss over here, guys, on the basis of Vieta's relations. Obviously, there are many more questions to do. Don't forget to like, share, and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is being discussed in the live sessions, not in these recordings, you can get the PDF of those sessions in the next 1 hour of the session. That's all we needed to do. Bye-bye. Take care, everybody.